Hello everyone, and welcome to this lecture in P80-105, a course on data science. This is the second in a collection of 3 videos on building blocks, things like code and project organization, reproducibility, and version control. In particular, this video is going to focus on writing with data using R Markdown. I'm going to start by giving an introduction using slides, and after that I'll demonstrate the material using a screencast. Feel free to skip around to the parts you find most useful. To get the most out of this video, I encourage you to code along with me. All this material is available at p80-105.com. There are links in the description below. Awesome, let's get started. Okay, I want to spend a little bit of time talking about writing with data. This is going to talk in general about the process of writing with data, and I'll also talk a little bit about how we're going to use R Markdown to write with data very specifically. One of the things that I think happens when people are getting started in data science is that there's a tendency to underestimate how important it is to write well and to underestimate how much time you're going to spend communicating in writing. It turns out that there are a lot of people that you end up communicating with in writing. Often those are collaborators. Sometimes that collaborator, as I've said in other videos, sometimes that collaborator is you just 6 months in the future. And the more that you can write down and the clearer that you can write things, the better off your collaborators, including you, are going to be. Sometimes that writing is about how you have cleaned the data to make sure that everybody knows what is going on and that that's been done appropriately. Sometimes you're going to write about analyses that you've done. Sometimes you're going to write about the results that you've gotten. Sometimes you're going to write about all of those. But you're going to spend a fair bit of time writing stuff in text rather than just producing code and producing tables and producing figures. This can take a variety of formats. Sometimes you're going to be writing these things up as reports. Sometimes you're going to be writing up blog posts. Sometimes you're going to be writing some technical description of something that you did, either so that you or somebody else can understand the code that you've written. Sometimes this is going to be emails and replies to questions. The point, though, is that you are going to spend some time, a fair bit of time, writing things down, and that's something that is worthwhile to be deliberate about and to spend some time thinking about how to do well and to get better at it. One of the things that comes up when you start writing with data is how you are going to do that. It is, as we've said in other cases, it is always true that one of the ways that you are going to communicate effectively is going to be code. Code is going to be the thing that implements the analyses that you've done or the work that you have done to produce some result. And so code is a central part of the things that you're going to produce, but it is often not sufficient. That code needs some explanation to be clear to somebody else, and that results need some explanation to be clear to somebody else. And so one of the things that greatly facilitates the process of writing with data, especially if you are going to think of code and text as being 2 pieces of that written report, is to use a tool that allows you to both write code and write text about that code and about those results. Now this facilitates reproducibility, and reproducibility is a big concept that we're not going to get into too much right now, but the basic idea is that given some data and some code, others should be able to reproduce each step of an analysis that you have worked on. And even better, not just reproduce that step or reproduce those outputs, but understand how those things were implemented and why they were implemented in a particular way. So if you can include both code and text and results all in one place, and do that in a way where everything is going to be clear to somebody else, well, that's going to make reproducibility a lot easier. It doesn't guarantee reproducibility by itself, but it is a big component of that. So again, when you are writing things down, if you can put code and text and results and descriptions of those things all in one place, that's going to go a long way to making sure that everybody understands why you did what you did and what you got out of that process. There are a variety of tools that make this possible. Jupyter Notebooks are one thing. Long time ago, people were using SWeave. What we're going to use, thankfully, is R Markdown, which is a really useful tool for writing things in a reproducible way, for writing reports that allow you to combine text and code. Now, I'll talk more about R Markdown in a couple of minutes, but first I want to give you a few general tips about just writing with data in general. And some of these are tips about writing in general. The first thing is to know who your audience is. Are you going to be writing this for somebody who really has a strong understanding of statistical methods or machine learning or tools for reproducibility and data cleaning? Or is this somebody who really wants to know about what the results are and how you might interpret those results. So how knowledgeable are they? What do they want to know? What do they need to know? Do they need to get in the weeds of the steps that you have taken to do data cleaning? Or is it more of interest right now to get top line results and understand what an analysis produced? So know who your audience is and what they want to get out of something that you're writing. And then say clearly exactly what you did. And this is it's a difficult balance to strike, because you want to say all of the things that you did that are important. You don't want to leave some important step out or assume that somebody will reconstruct that, but you also don't have to give a step-by-step deconstruction of every single thing that you did. Again, what's important will depend a little bit on who you are writing for, and so keep that in mind then when you're sort of putting a report together. There's a general structure that I recommend when you are writing with data, and this works for almost every kind of a written thing that you might produce. You often want to have some introduction or overview, why it is you have put together some report, why you have put together some document, what is the thing that you are trying to do. That can be brief, that can be long. You want to have some idea about the data and the methods that were used. And here, I think it is often helpful to describe where the data are coming from. Is it in a spreadsheet? Is it in a combination of things? What did you have to do? Any steps to import that data that are not obvious? Anything to clean data that is not obvious? What happened to the data? Then what kinds of summary statistics are there? And when I say summary statistics, I mean after you have data, how many observations do you have? How many variables do you have? If you are looking at some data set that includes variables like BMI or age or gender, what was the average BMI? What is the average age? How many people fall into each of the gender categories that you're interested in? Those things can be very useful checks for you and for others to make sure that whatever data cleaning process you've implemented is actually correct and that everybody's on the same page about that. In your report, you probably want to talk a little bit about the exploratory analysis that goes beyond things like age and gender and means and variances of those things. You might want to do some tables or some plots or some other things. And then if you are going to produce some formal analysis, you want to describe what that formal analysis is and then how that has been implemented if there are any questions about that. After that, you're going to have some results that you want to show. That might be tables, it might be p-values, it might be coefficients. It could be all sorts of different things, but you'll want to have some results. This is what I got when I did these things, and then maybe some discussion of each of those. Now again, this structure holds in almost everything that I write, and sometimes those are very, very short things. It can be an email that says, I'm following up on a question about this. I used these data that I got at this time, and here's what I did, and this is what I found. Or it can be a much longer report. Sometimes, like I say, these are long. Sometimes they're a sentence. It sort of depends on what the document is being used for. I'm going to talk in just a little bit more detail about some of these steps, but again, there's an introduction. What is the context for this? Why are you writing this report? What are you hoping to do in the document or the thing that you have written? What is the goal that you are trying to accomplish right now at this time? Data, I spent a little bit of time talking about, but again, what are the things that you had to do to import data? What are the things that you had to do to clean data? What are the things that you had to do to edit data? Were there any issues that you saw? Were there any things that you're not sure if it means missing value, or you're not sure if the variable coding is correct, if there's any ambiguousness? What are the questions that you had and how did you answer those things? All of that, I think, is worth describing in some form in the data part of your report, whatever that report looks like. And then again, some kind of summary to make sure that there are external checks on the kinds of things that you've done. What are the sample size? How many variables do you have? What are maybe the names of the major variables in your data set? And is there some way to report like a mean or a proportion of the major variables that exist there? Following that, again, there are going to be methods and models. This is one of the elements that we are not going to spend an awful lot of time talking about in the context of this class, in the context of P8105, but often you're going to want to do some kind of an exploratory analysis. Visualizations we will talk about, other kinds of summaries maybe we'll touch on, but formal analyses, things like the regression models that you might fit, or the machine learning approach that you might use, the statistical significance that might come out of those. Again, you should report all of those in details. We're not going to spend a huge amount of time talking about how those things work, but they're important to describe in whatever you're writing up. And then what did you find when you did these things? Either in exploratory analyses or in data cleaning, where there are missing values, as I said. Is there something that you're not sure about? Are there any real obvious features of the data that you want to draw someone's attention to? What happened when you did the modeling? What is your final model? What are your results? And what are the conclusions that you want to draw from each of those? The discussion here sort of touches on many of the same things. Are there any open questions, I think, is an important thing to do? Are there limitations of your data analysis? Are there next steps that you think you might need to take, either you as an analyst or part of the team that you are working with? What are the next things that you need to do in the context of this data set or this data analysis or this general problem that you're interested in? Now, that, I think, is a useful overview for how you should go about thinking about things. And as I say, that's a structure that I use in almost everything that I write. But it takes some time to get used to working in that context. It takes some time to get used to structuring the things that you're writing. And it takes some time to get used to writing each of those elements independently. So I do want to be clear that writing isn't always easy, and it doesn't always come naturally to folks who gravitate towards data science. It doesn't always come naturally to people who want to focus on doing data analysis. But to be effective in doing data analysis, you have to be able to communicate that. So even if this isn't easy, and even if it doesn't always come naturally to you, you can get better using practice, and it is important to do that practice, because writing really is an important skill. It's going to be one of the things that you do most often to communicate the kinds of work that you're doing as a data scientist. Now, I'm going to take a step back and at least acknowledge some of the things that happen when you start doing data analysis, and I'm going to describe this in the context of how you might communicate those things. Now, this is a flowchart that we're going to revisit. It comes from R for data science, and you'll see it in other places if you start reading up on data science in other sources. But the basic idea is that often the first step is to import the data, the next step is to tidy your data, and then here in this box there is what's called understanding, and roughly speaking that is, what data transformations do you have to do? How are you visualizing those things? Once you've done some visualization, what is a model that you might take? And does that model then imply some other data transformations that you might do? Does that model say there are other visualizations that you might do? There are other modeling strategies that you might approach. And so you find yourself very often in this sort of loop here in the middle where you have imported data, you've cleaned that data, and now you're really trying to understand what's going on. And then eventually you exit this loop and you need to communicate effectively what's happening. Now this sort of paints it as, sort of a nice little cyclical feature. I think very often it ends up, data analysis reminds me more often of the game Chutes and Ladders, and I'm not even sure that this is a game that is still around, but it's one that I played growing up. And if you're not familiar with this, it's a game that looks something like the following. You start at square one and you roll a dice and you make your way across this board, and if you happen to land on a square with a ladder, you make your way up, and then if you make your way all the way through but you land on one that's on a slide, you can go all the way back to the beginning. And in the context of data analysis, that happens a fair bit, where you work with the data and you have some insight and you jump ahead, and then something happens where you realize that you have made some mistake, you've misunderstood a variable, you don't know exactly what's happening, there's some other feature that somebody is just telling you about, and you find yourself going back almost to the beginning to restart. So this, I think, is how data analysis works in practice. Very often when it comes time to report some data analysis that you've done, it looks like this, like you started at the beginning and it was just smooth sailing, it was a straight line, direct path, exactly where you wanted to go. And it was even scenic and pleasant on the trip there. Now, there is a bit of mismatch between those two things, what data analysis actually looks like and how you might describe that data analysis. And what I would encourage you to do is to be as complete in writing as you can without being distracting. So you should at some point say, these are the challenges that I ran into. If you find something in the data that sent you back to the beginning, add some piece about that to your description of the data. If there was some element that updated the model that you needed to use, be clear about why you needed to do some different approach than you anticipated at the outset. And mostly so that's later on, that's somebody else reading your report knows what you ran into, so that 6 months from now when you go back and revisit this problem, you don't have to remind yourself what happened. You can just read through and say, oh right, these are the challenges that I ran into, right? So it's useful to strike a balance between every single step that you've done and just like a clear description of what actually happened. This is an example that I like to use. It is, you often, I say striking the balance between being complete and too complete is a little bit challenging. So this is an example from a year or two ago now. I was working with an analyst and they put together this report, and somewhere, this is page 23 of 36, this is a printout of the data set that we were using. And here it is on the next page and the next page and the next page. And that was probably not the most useful thing to include in the report, is the entire data set. I don't think, it's true in some sense that that's being very complete, but I don't think that was actually a good use of that reporting space. So you want to be complete, but don't take it too far. And that's, striking a balance is, again, one of those things that you have to practice. You will get better at. You're going to write a lot, and you will find yourself thinking, is this the right amount of information for the people that I am writing for? It takes some time, it takes some practice, but think sometimes of yourself, put yourself in your target audience's shoes and ask, if I were receiving this report, what are the things that I would actually need to see? If I were reviewing this, what are the questions that I would have, and what would I need to do to have those questions answered quickly and clearly? Okay, so now I'm going to shift gears. I think all of that is sort of thoughts on writing with data in the first place. And now I mentioned that we want to come up with a tool, or we want to use a tool that is going to allow us both to write text and describe our results, but also to include the code and the results that come out of a data analysis that we've worked on. And so we're going to use R Markdown, and you may have heard of this and not really understood what's going on, or you may have heard of this and used it in the past, but I think it's helpful to spend some time understanding what exactly R Markdown is, how it's used, and why we're going to use it. A step back, the first thing to understand is what Markdown is, what a Markdown language is. And I'm describing it as a lightweight syntax. And you can think of that as something that looks almost like text, but that allows you to include some things that say, these words should be bolded, and this should be underlined, and this is what a list looks like. And if you write text using that syntax, that it can then be converted to another format, like HTML, like a PDF document, like a Word document. You may have run into Markdown languages in the past and not used them. There's sometimes used, Slack, for example, allows you to bold words by putting little asterisks on either side of them. Some websites allow you to format comments using something like a Markdown language or a Markdown syntax. So you may have seen things like this in the past, and you may not have. R Markdown takes one step back from that and says, in addition to having that syntax that allows me to format text using bold and italics and uppercase, lowercase, or section headings and tables and things like this, is it possible to include in that code chunks, bits of R code, and then the results of those code chunks? And so the process, the workflow that works with R Markdown is you start here with an R Markdown document, and then there is a piece of software that converts that R Markdown document to a more standard Markdown format. Now, the Markdown format is one that is generally understood by computer languages, and there is another bit of software that can convert a Markdown document to some other format. And so what we're showing here are just sort of three different things, but you can convert using Pandoc. You can convert Markdown to a PDF. You can convert Markdown to HTML. You can convert Markdown to Word documents. You can convert Markdown to a variety of different things. Now, a lot of this pipeline, a lot of this process is not going to be something that you have to worry too much about, assuming that you have installed the correct software. You'll be able to write your Markdown document and say, please now generate a HTML document. Please now generate a Word document or a PDF. Now, the goal, again, here is to start with one piece of written information that includes both the text that you care about and also the code that is used to produce the results and also the results themselves, to have all of those in one place, because that is going to make your workflow really, really smooth, rather than having code over here and results over here and some written description in a third place. I'm noting here the knitter function is something, or the knitter package is actually an R package. It's produced by the same folks who do a lot of other things at RStudio, and this is maybe the first opportunity that I've had in this collection of videos to introduce these hex stickers. This is a real sticker you can get and put it on your laptop if you're a big fan of knitting R Markdown documents to Markdown documents. Okay, and with that, I'm going to stop doing this and have a screencast in which I demonstrate some of this material. Awesome. All right, awesome. Let's do some stuff with R Markdown. As I said, this is the second in a collection of 3 videos that focus on building blocks. And in the previous lecture, in the first of those 3, I created a directory on my machine called building blocks, and inside of that, I created an R project. And that's what I'm going to open now. Okay. I've got now a few options for creating an R Markdown document. So you can, for example, go to File, New File, R Markdown, and inside of R Markdown, you'll be able to create a new document. You can also create presentations. We won't get into that so much. You have some output options. You can create an HTML, a PDF, a Word. I'm actually not going to take this approach to create this document. What I'm going to do is download a template that exists on the p8105.com website. So over here, I'm going to launch Safari, my web browser. I'm going to go to p8105.com, and what I need to do now is navigate to that template. So I have under templates, building blocks, that's the collection that we're in. Again, this is the second of those topics in building blocks, writing with data. And now inside of this, I've got both printed here, something that you could copy and paste into an R Markdown document. I've got printed here a basic RMD file, but there's also an option to download this template using this link, and that's what I'm going to do. So I download this, and then in the interest of keeping everything for these 3 lectures in the same place, for these 3 videos in the same place, I'm going to take that template and I'm going to put it into building blocks. Now over here, I could open that folder, I could see what's going on and navigate to this. Instead, I'm going to click the Files tab in this panel of the RStudio IDE, and I'm going to open here are all of the things that we've created up to this point, and I'm going to open the template Markdown document. Now, I want to walk through a few of the key elements here in Markdown, and then we'll knit this to see what it produces. Now, the elements of this Markdown document are the following. There are these few lines at the very beginning that are referred to as the YAML header. We'll talk more about what these do, but they, generally speaking, define some of the attributes for the document as a whole. So here I am telling it that I want this to be called simple document, and the title of this to be simple document, and I want the output to be an HTML document. Now, after that, all of this is written text. This is stuff that I want somebody to read as if it were written in a natural language. So it says I'm an R Markdown document. I have something here that looks like a section 1. Hopefully that's going to turn into something that looks like a section header. There's another sentence. Here's a code chunk that samples from a normal distribution. The words code chunk have 2 asterisks on either side. And the normal distribution has an underscore on either side. Hopefully that turns out to be something that's useful. There's more text down here where I have maybe another section, and then I've got some more text that goes along with this. And then in the middle, I have what looks like and is in fact R code. I have something that says I want to draw a sample from a normal distribution, and then I want to ask what the length of that sample is. Now this R code is set off on either side with 3 backticks and an open bracket and an R, and that says in essence that what happens between these 3 backticks and these 3 backticks should be interpreted as R code and treated as such. Now I'll talk through some of the things that go along with YAML headers, with text and text formatting, and with writing R code and in chunks. But before doing that, I want to knit this document and see what happens. Now again, knitting is the process that takes an R Markdown document and converts it to a Markdown document. And then we'll actually also take this a step further. We don't have to worry about this part of things, but taking that Markdown document and converting it to some final output format. We're going to convert this to an HTML document. So when I click knit, optionally, I think it's Command-Shift-K or Option-Shift-K. If you click knit, some stuff happens in this R Markdown tab. You get some output here. Sometimes that will be informative, sometimes not. We'll see some of that at some point. But the main thing that I want to draw your attention to is what's happening over here in the viewer pane. Now, in just a second, I'll describe why what you're seeing in R Markdown might differ slightly from what I'm seeing in R Markdown. But first, I just sort of want to talk through what we have produced. So here, the title at the top of this document is simple document, drawn from the title in YAML. There's text. I'm an R Markdown document. This Section 1 is being drawn from the Section 1 here. The text that I wrote, here's a code chunk that samples from a normal distribution is being output, but I've done some formatting as well. So the two asterisks on either side of code chunk make those words bold, and the underscores on either side make normal distribution italicized. The next thing that happens in my document is I come across this R code chunk, and what is produced over here is that same code has been outputted, but it's formatted in such a way that makes it clear to somebody reading this that this is R code. And just below that is the output that one would get if they executed those two lines of code. And just to confirm that's the case, I can highlight both of these lines and press enter to execute something from my script, from my editor on the console. And sure enough, I draw this sample from a normal distribution with length 100. And if I ask how long that sample is, how long is that vector, it gives me a length 100 vector. And then after that, I move into some additional text. Here I've got section 2. I didn't note this before knitting the document, but it turns out that you can combine both written text and something that says, I would like to compute one little bit of R code right here and include it in this sentence. So for example, if I wanted to know what the mean of this sample is, I can ask to compute that mean and include it in a sentence, and sure enough, here it is. Okay. Now I said just a second ago that what you see in RStudio might differ a little bit from what I see in RStudio, and I'm going to talk about why that might be the case right now. And this is mostly related to the preferences that exist in RStudio. One thing that can happen is instead of highlighting these lines of code and pressing enter and seeing the output down here, in some cases you will see the output directly below this. That structure is closer to a Jupyter notebook, and in fact is something like an R Markdown notebook, which is another file format. It's something that I don't particularly like, but that's as much a matter of taste as anything. And I'll talk a little bit about that in just a second. The other thing that can happen is I am seeing this output over here in the viewer window. Sometimes that will pop up into a dedicated, like a new window. Both of these are things that exist in RStudio preferences under R Markdown. So here I am not showing, I'm not outputting inline for all R Markdown documents. And here, show output preview in, I'm saying in a viewer pane rather than in a window. Again, that's going to be sort of up to you, but in case there's some confusion about what's happening by default, I wanted you to be aware of it. Now, I'm going to talk in more detail about the three elements of a Markdown document. And I'm going to talk about these in an order that's a little bit different. So I am going to come back to the YAML header, and I am going to talk a little bit more about formatting text. But I think the thing that really makes R Markdown unique, that makes R Markdown powerful, is the ability to include code chunks. And so that's what I want to start out talking a little bit about. What I'm going to do is insert a new R code chunk, and you can do that by typing 3 backticks and then a curly bracket and an R and a curly bracket, and then enter a couple of times and 3 backticks again. But I encourage you to use the hotkeys that will insert these automatically. On a Mac, it's Option Command I, and on a Windows, I believe it's Option Control I. If you do both of those things, if you hold Option Command I all at once, and you should get this code chunk. Now, what I'm going to do is write some code that is similar to something that we saw in the lecture on best practices. I'm going to create a data frame, I'm going to create a tibble, and I'm going to make a plot based on that tibble. So I haven't said an awful lot in the past about why we need this, but I am going to start out by asking for the tidyverse library to be loaded. Again, we will spend more time talking about what the tidyverse is and why this statement is necessary. In short, I'm going to use a function that comes from that extension. I'm going to use the tibble function to create my data frames, and so I need this line of code to tell R that the tibble function exists. Now I'm going to create that data frame. Let's create plot.df, again giving something a somewhat informative name. I'm going to use tibble to create this, and let's just say x is R norm, let's do 500 this time. And I'm going to set the mean to 2 and the standard deviation to 4. That 100% doesn't matter. I just felt like it. And what I'm going to do next is create a y variable. Again, I want to make a scatter plot with x on the x-axis and y on the y-axis, so I think these variable names are reasonably informative here. And I'll do 3 minus 4.2 times x, and I want there to be some scatter on this as well, so I'm going to use R norm again, and we'll just call this 500. Okay. And then the last bit of code that I want to have here is a plot. And this code is going to look like something that we saw in the video on best practices. If it doesn't make sense yet, we haven't spent a lot of time talking about ggplot. We will before too long. But again, I'm going to use the ggplot function, and I'm going to use that to create a plot based on the plot.df data frame. I have to tell ggplot what goes on the x-axis and what goes on the y-axis, and then you need to tell it what kind of a plot I want to make, and I want to create one that's got little points for all of the different elements in my data set. Now, there are a couple of different things that I can do now. I can highlight this entire code chunk and press enter, and it will execute that code chunk on the command line. Now, this I think it's helpful to understand really that there are sort of two things that are powerful here. One is that I can write code in an R Markdown document and edit that code and update it in the same way that we have seen in R scripts. And so very often, this is how I go about writing code, is I have an R Markdown document where I say, this is something that I want to do, and then I create a code chunk here, I'll highlight my code, I'll execute it, and I'll see what the results look like. Okay, and I think that makes a pretty big difference. Now, the other thing that you can do is click knit, and it will update that document so that it is included in the output that we're seeing. So again, the first part of this I haven't changed at all. I've got my simple document, I've got section 1, and now here in section 2, we're seeing both the code and the messages that came along with that code. And then we see the next bit of code, plot.df and ggplot, and we actually see the plot embedded in the Markdown document. And so all of this is happening in one place. Now, something that's helpful here is that I can add some text describing what I'm doing so that this code chunk actually, I think, makes a little bit more sense. So the code chunk below creates a data frame and generates a plot. And we can describe the results also. This plot is really great. It shows a linear relationship just as expected. Okay. And this, as I say, the process that I'm demonstrating now is really the way that I go about writing code and writing documents and documenting that code. So I have here the code that I want, and I've got on either side of that some text that describes what that code is intended to do and the results of that code. So there are some options in R Markdown that make it possible to tailor the kind of output that you're going to see. And I'm gonna describe at least a few of those options now. The first thing that I like to do often, but not always, is to give my code chunks names. So this one is going to be plot example, we'll call it. And what that does is, it's not maybe super clear now why this will be useful, but later on, when you have documents that have 10 or 15 or 20 different code chunks, if one of those code chunks contains an error, the R Markdown tab will tell you in the code chunk named this, that's where the error is coming from. And that turns out to be a pretty handy thing to have. Otherwise, you're going to sort of be scanning through to try to figure out why there is an error in the unnamed code chunk number 13, and you'll have to sort of figure out which one that is. Now, you don't have to name these, but again, it's generally speaking a good habit to get into if you're able to do it. Now, you're able, I think, to do some, you're able, I know, to do some other things that I think are a little bit more useful. One of those things is whether or not you want that code to be evaluated. By default, this is going to be true, but you can set that eval equal to false, and that turns out to be helpful because it gives you a way to export code, to show code, but to not actually execute that code or to generate the results of that code. That is often helpful if you have something, you know, a method that, or sorry, an implementation that you used at one point and don't want to forget about, but that also isn't necessary in the final analyses that you've done. You can turn off using echo, you can make the code chunk run, but not be exported. So here I still get the messages and I still get the plot, but I'm not showing that code. You can turn the message off using message equals false. So here I have turned off both the code chunk itself and also the messages, and I'm just showing the output and describing it. You can, I think, turn something off entirely using include equals false, and what that's going to do is act as if that code chunk didn't exist at all. It's not going to export the code, it's not going to export the results, and so I think those are probably the most useful options that you're going to end up with. I guess there's another one. Let's try collapse equals true. And what collapse equals true does is it sort of collapses the output of a code chunk all into one place rather than sort of doing a line and showing the output and running a line and showing the output. So all of those I think are useful code chunk options in the context of R Markdown. And some of those will be things that we end up saying, in general, I want to turn messages off, or in general, I want to leave these things on. We'll talk a little bit about that at another time. But in general, what I encourage you to use these code chunk options to do is to understand who is going to be reading this and what do they actually need to see. In this example, I would probably turn the messages off because we don't really need to see this printed information, but I would leave the code in because it's potentially useful for somebody to see that code, and I would want to include that in some written report that I've generated. There is another thing that we might try to do. I highlighted this here, and I'm bringing this up in the context of our code. This is not for a code chunk, this is for inline code. You can compute things like the mean of a sample, and that's what I've done here. I find that is helpful in some ways and for some things. So one thing that I might end up doing is to say the dimension, sorry, the data frame has, I'm going to use one backtick and an R, and the R command is in rows. I want to know how many rows exist in my plot data frame. The data frame has in rows plot df rows. So now if I knit this, in rows is not the right one. Let's see, in row. That's correct. So now what I'm saying is the data frame that I've created has 500 rows. And you might think to yourself, that's not a particularly useful thing, but I could change this to 1,000. And then when I reknit this document, that line of text will be updated to reflect what actually happened in my data set. And believe it or not, this is the sort of thing that is helpful when you are doing data input, when you are doing data description, is to say, I read in this data and I got 327 observations, and to have that be automatically generated so that somebody who reads this can say, oh, that's the correct number, or no, that's not really what you should have ended up with, and we can go back and talk a little bit more about that. So inline R is helpful. I think it is obviously much less helpful than the ability to include longer code chunks, but it is something that's a little bit useful. Now, what I want to talk a little bit about next is formatting. So we've done a little bit of text formatting. I'm switching gears from R code and code chunks to other things that might appear in the document and how you might want to go about formatting these things. I've talked a little bit about what we're seeing here. It's somewhat unfortunate, I think, that here to do section headings, you start with a # or a hashtag. In the context of R code down here, this is a comment. Outside of a code chunk, this is going to indicate a section heading. And that mismatch is maybe a little bit confusing, but keep in mind the stuff that is outside of a code chunk is not code and it's not going to be interpreted as code. This is just formatting that we're using in the context of Markdown. I also talked about making things bold here and italicized here. I'm going to create a new section down here. So this is, let's call it section 3. And I'm actually going to create a subsection here. If you want subsections and subsections, you can do that. This is data frame and plot, we'll call. So if I knit this, I have a subsection. I could make this a little bit smaller probably by making it a subsection. Sure, and you get something that's a little bit smaller. So you can control, to some extent, the structure of the document that you're creating using that kind of a code chunk. You can format things so that they look like code. You can create superscripts and subscripts. I'm not going to spend an awful lot of time doing either of those things. I think that's helpful though, or it's helpful to know that those things exist. You can create lists. So here is a list. This is my first list item, and lists need at least 2 items. And I'm going to indent a couple of times. This list has a sub item. And let's just, for the fun of it, this is exciting stuff, we're making lists. I'm going to put in a third thing here, and I'll just call this third list item. So great, let me knit this and make sure that everything works about the way that I intend it to. And sure enough, you can put in a list doing something like this. A last thing that I'm going to mention that is possible, let's make this, how many subsections did I have here? Let's put in a table. Now, table formatting is a little bit strange, but I'll say column 1, and then a vertical bar, and column 2. And then I'm going to put a bunch of horizontal lines here with a vertical bar in the middle. I think this works. And then I'll say, let's call this A, B, C, and D. I'm going to cross my fingers that this works, if I'm honest, and I'll tell you why in just a second. It worked. Great. What's nice about this, again, so the columns are being drawn from column 1 and column 2, and the table items are A, B, C, and D, and everything shows up. And the reason that I was a little bit nervous about whether or not this was actually going to work is that I rarely type tables into R Markdown. But the reason that I want to be clear that this exists is that sometimes in a data analysis process, the result is going to be a table. And if you have that nicely formatted in your R output, then it turns out that you can create nicely formatted tables in the context of an R Markdown document without too much additional work. So tables exist and you can make them. I encourage you not to create tables by hand. I think that's a silly thing to do. But we're going to see in some later cases that you can create these tables and they have nice formatting at the end. Now, if you're sort of thinking like, I'm never going to remember all of that, there are some online resources, including on the P8105 website. We've got some lists here for how you might format text. At the very bottom of this page, there is an R Markdown cheat sheet, and this R Markdown cheat sheet, the older version, has some information about formatting. So here's how you do superscripts, and here's how you do equation blocks, and here's how you do some other stuff. So there are resources for the kinds of things that you might want to end up doing in the context of formatting text, and I'm not going to spend too much time on that because, at least in my experience, once you get a little bit beyond some of the basics, I usually don't remember, for example, how block quotes work. It's helpful to know that that does happen, so that if you want to insert a block quote, you can do that. And what I mean by a block quote is, this is a block quote. Great. So now I've got if you want to quote a paragraph somewhere in a document, you can do that. But again, I'm not going to spend a huge amount of time talking about how you format text. Other than that, in the basics, you're going to sort of remember the quick things, hopefully relatively quickly. You'll think about section headings and titles and maybe bold and italics pretty quickly. Other things exist, and you can find descriptions of those online. R Markdown and Markdown turn out to be pretty flexible, as it turns out. Okay, so again, I said at the outset that there are a few different elements of a Markdown document. I've talked about code chunks and I've talked about formatting text. What I want to talk a little bit about next is the YAML header. And the YAML header is this stuff that's defined up at the very top. And there are a few things that you can add here. So you can add an author element. The author is Jeff Goldsmith. You can add a date element, let's say August 2020. I think this is going to work for us. And so here, sure, I'm creating a document that includes some of that information, and that information is included in a structured way at the beginning of this document. But there are other things that you can do, other ways that you can control the behavior of the document that you're interested in, and those turn out to be really helpful. And so the first one that I'm going to point out is that so far we have been outputting an HTML document, and we're still going to do that, but I'm going to put HTML on a new line and put 2 spaces. YAML is very picky about spacing, so I'm being careful about this. And then I'll enter again, and this time it got it right. It knows that I want to indent again. And so what I'm going to do here is add a table of contents by saying TOC is true. And let me knit this and make sure I have my spacing right. Yeah, so I've got this table of contents here, and if I click on, say, section 3, it'll take me down to section 3. Now you can also, and this is where some of the stuff in HTML starts to get a little bit fancy, you can do things like TOC float is true. So let's knit this again. And now you'll start to see this isn't looking quite right for what I'm interested in. So I'm going to click this button in the RStudio IDE, which is to show this in a new window. And since this is HTML, it's actually going to open this in my web browser. And now I've got this table of contents floating along the side that I can click on. But as I scroll through, it all stays in the same place. And so that if you have, it looks like subsections are not showing up, but if you have subsections, that also sort of shows up in this floating table of contents. Now, as I said, it turns out that HTML is a helpful thing to have because it enables you to take advantage of some amount of user interactivity. And so what I had here, for example, is the ability to click and navigate using this drop-down menu. Another thing that I use pretty often is code folding. So let's see, code folding, and I'm going to set this to hide. Let me knit this. This is one I usually copy and paste. It looks like it's worked, so let me reopen this over here. Now, the document looks almost the same, but one of the things that's different is that my code chunks have been hidden, and so if I click this code button, it will show that code chunk here. Make sure you can see. You can click and hide the code chunks that you might want to include. Now this, I find, is often helpful if you know that some people are going to be interested in seeing some of the code and other people are not going to be interested in seeing some of the code. And it turns out to be a YAML option for HTML documents that is helpful. There are, since all of this has been under the HTML output format, I am going to be clear that there are other output formats that are possible. So I'm going to say, let's make a PDF document and cross my fingers on this one. Yeah, so it's created here a PDF document with all of the same stuff. It's still a simple document by Jeff Goldsmith in August 2020. It's got, I'm an R Markdown document. It's keeping the text formatting, code chunks, normal distributions. It's showing that code chunk. It's including the output. And all of this is in the context of a PDF document. Now, one of the reasons that I hesitate a little bit about talking about PDF documents is that it relies on an additional bit of software. So that bit of software is called LaTeX. LATEX. It's pronounced LaTeX. It looks like latex. And that is sort of the underlying engine in that process where you go from R Markdown to Markdown to now PDF. The thing that converts a Markdown document to a PDF requires that LaTeX installation. And so PDF documents are something that you can get to if you need to, but might not sort of work off the shelf. And a similar thing, you can create Word documents. Word documents are helpful if you are going to be collaborating with people who are more comfortable using Word than they are using, I have no idea what's happening here. That was weird. Let me just double check. Right. All right. So again, I don't know why Skype opened with Microsoft Word, other than that I guess now they're both owned by the same people. But I am going to come over here and open this template.docx. And so it's got all of the same stuff. It's got the title, it's got my name, it's got the date, it's got sections, it looks the same, right? I don't especially love the default styling on this. That is something that you can update if you want to. And I'm a bit distracted at the moment. My cat Ted has a tendency to show up when I am trying to record some of these videos, and Ted is now right here between me and the computer screen, and he's really curious about what's going on. Ted, you're gonna have to continue on there, buddy. All right. As I was saying, you can export Word documents, you can export PDFs, you can export HTML documents. What we're going to see in a later video, probably the next video in this collection of 3, is that you can also export things that are called GitHub documents. The ones that I end up using most often for myself are HTML documents. I find the interactivity helpful. In working with some collaborators, I will export Word documents and try to change the styling in a way where the visuals aren't quite so bad. We're not going to have an opportunity to get into what's called the redoc package, but redoc, it turns out, is helpful. And if you find yourself using this in your own work, and once you get comfortable using R Markdown in general, it might be worth doing a little bit of reading on. The redoc package allows you to incorporate track changes. So if you send a document to somebody else and they make some changes, you can import those changes back into your R Markdown document. That's helpful, but if I'm honest, a little bit fragile. Sometimes it works and sometimes it doesn't, and it can be quite frustrating. But I think a lot of the time what I use is GitHub documents, because a lot of what I publish, or a lot of what I write, ends up on GitHub eventually. And we'll talk more about that output format down the road. Now, all of this together, I think, is still suggesting a general workflow that we might want to use. And that general workflow is pretty similar to what we talked about in the first lecture in this collection of 3. You want to create a directory that has everything that you're interested in. That includes the data that you want to be working with, it includes the code that you want to write, it includes the output that you want to produce. And here, instead of using our scripts, remember in the last time we generated a script for data frames, instead of our scripts, I will generally encourage you to create R Markdown documents so that you can include text and R code all in the same place. The other thing that is helpful is in your workflow to make sure that things are reproducible by periodically trying again to make sure that something still runs. I said previously that you can do that by restarting R, but what's helpful in knitting an R Markdown document is that each time you knit this document, it will do that in a new R session. So if you write some code and you click knit and it doesn't work, well, that's probably what the issue is. And that's the process that I use for working with data across a very, very wide range of projects. And with that, I'm going to go ahead and end this screencast. Thanks very much.